continuation to the topic that an electric dipole kept in an electric field experiences a torque. Now we have to discuss the electrostatic potential energy of an electric dipole which is kept in the uniform electric field. When an electric dipole is kept in uniform electric field, we have studied torque acts on it. How much is the torque? Torque acting on the dipole is given by Pe sin theta, where P is dipole moment and E is electric field intensity. Dipole is kept making an angle theta with the direction of electric field. Now, due to this torque, if the dipole is turned, suppose through angle d theta, a small angle, then what is work done by the torque? Work done is given by tau d theta. In case of rotation, the torque will replace the force and d theta angular displacement will replace ds, that is linear displacement. In place of torque, we write Pe sin theta and then d theta. Now, if we find the total work done in rotating the dipole from 90-degree orientation, that is from an angle of 90 degree, this 90-degree position is considered as the reference orientation. So this is considered as the reference level when dipole is rotated from an angle theta is equal to 90 degree to the angle theta with the electric field. Then work done is given by integrating the previous result Pe sin theta d theta integrated from limit 90 degree to theta. On integrating, the Pe, both are constants taken out. Sin theta integrated becomes minus cos theta. When we put the limits, cos theta minus cos 90. Cos 90 is 0, so the work done becomes minus Pe cos theta. As we know, dipole moment and electric field intensity are vector quantities and work done is scalar. So we write it minus P dot E. Now this work done by the electric field in rotating the dipole from a reference position to certain angle theta is stored in the dipole in form of its electrical potential energy. So potential energy is given as U is equal to minus P dot E. What is the significance of this minus sign here? Minus sign is basically an indication that work has been done by the system itself. The system is comprising an electric field which is uniform and an electric dipole. So work is being done without any role of an external agent. Work is done by the electric field itself. So the sign negative is coming in the formula of potential energy. Exactly the same way as in class 11th you have studied the gravitational potential energy. Gravitational potential energy of a body was given by the formula Gmm upon R, because in this, when body is brought from infinity, that was the reference point where potential energy was 0, to certain point in the gravitational field, because Earth was doing the work, so the sign of potential energy was negative in that case also, minus Gmm upon R. Now in this situation also, the dipole is being turned from a reference position of 90 degree to certain orientation that is represented by angle theta. The work is done by the system itself, so minus sign we are getting in the formula. U is equal to minus P dot E. This is also possible that we take the reference position as 0 degree orientation when the dipole is parallel to the electric field. If we take the situation that theta is 0 degree as reference, then the work done is obtained as, it will be W is P E sin theta d theta. Rotation is from 0 to theta. Pe constants, sin theta when integrated becomes minus sin theta, that we are taking outside, and this is 0 to theta. It becomes minus Pe cos theta minus cos 0, and the result becomes minus Pe cos theta minus 1. We can also write it Pe 1 minus cos theta. So the potential energy becomes, it is Pe 1 minus cos theta. Both the results are correct. You can take this case or you can take this case, as when we are starting with a 90-degree angle, the result we are getting is minus P dot E. Easier to remember, always generally represented by potential energy is equal to minus P dot E. So as potential energy is a physical quantity whose reference makes no difference, because in all the situations we are having a concern with change in potential energy, which will be the same whether we use this formula or we use the formula potential energy is minus P E cos theta. So we always use the easier one, that is minus P dot E. Now we take some special cases. The one is when dipole is in stable equilibrium condition. Then potential energy is, stable equilibrium condition means theta is 0. Potential energy becomes minus Pe cos 0, that is minus P into E. In unstable equilibrium condition, that is theta is 180 degree, so potential energy becomes minus Pe cos 180, that is plus P into E. And when dipole is at right angles to electric field, then theta is 90 degree and potential energy is 0. Normally we think when potential energy is 0, that is the position where dipole has minimum energy, but no, the minimum energy position is when the dipole is in stable equilibrium. That means the dipole is parallel to electric field. This is minus Q and this is plus Q. Dipole moment and electric field are parallel, they are in same direction. This is the situation when the potential energy is minimum, and when the dipole is kept in such a way that the dipole moment is opposite to the direction of electric field, like this is minus Q and this is plus Q. P and E are anti-parallel, opposite to each other, then the potential energy will be maximum. This is the state of unstable equilibrium. So minimum potential energy is when theta is 0 and maximum potential energy is when theta is 180. One more thing we have to learn in it. So when dipole is rotated from stable to unstable equilibrium position, the work done is required or energy is to be supplied from some external agent. And how much is that energy? It is given by final energy minus initial energy, and this becomes 2 into P into E, because energy was less in stable equilibrium and it is more in unstable equilibrium. So this increase of energy is to be supplied from outside, or this energy will increase at the cost of external work done. Opposite to this, if dipole is turned through unstable to stable equilibrium condition, then energy will be released in the form of heat or in some other form. And how much is the release of the energy? It is the same, P final minus P initial minus PE minus PE, that is minus 2P into E. As in unstable equilibrium energy was greater and in stable equilibrium it is less, so the extra energy is to be thrown out, and that is the change in the energy, minus into 2 into P into E. For any other two orientation, means not stable or unstable, in any other two orientations, the energy change is given by final minus initial potential energy minus Pe cos theta 2 minus Pe cos theta 1, which becomes minus Pe cos theta 2 plus Pe cos theta 1. So this is the electrostatic potential energy which is possessed by the dipole whenever it is kept in a uniform electric field.